All right, guys, here's video 2 for Unit 7, Lesson 6. So hopefully you look through these hints for how you prove identities. One thing that's important to point out for proofs, right, is that really you're supposed to start with one side. So this says either left or right side, and get the other side. For me, this method too, this is really more for show that, right? Because it's a little bit less formal. So I'm going to put that manipulating both sides is a little less formal. So yeah, it's more acceptable when you see show that. Okay, technically for a proof, you want to take one side all the way through and obtain the other. Usually it's easier to work with the more complex side first, right? So you take a more advanced or more messy looking equation or expression and simplify it. It's good to, add, subtract, multiply, divide, or factor when you see that that's the form that you want on one side. Multiplying by 1, top and bottom, same form can sometimes get you the expression that you want. This is a nice one. If you have no idea what to do, you can write everything in terms of sine and cosine and try and go from there. And then, this one is just here to say these are tough. All right, so there's gonna be some trial and error, but the more you do, the more you'll be used to kind of seeing certain situations and getting comfortable with manipulating the IDs. Okay, so and this one again too, guys, because I'm doing these blind. Don't be surprised if I use this strategy fairly a lot in trying to get these identities. All right. So first one, prove the identity 1 plus sine 2 theta is equal to sine theta plus cosine theta. So I'm actually going to work with this. Might be a bad idea. And you know what? And actually I changed my mind already because I know that sine 2 theta is 2 sine theta cosine theta. So I'm going to work with this because I know when I square it out, I'm going to get this. All right? So what I'll do is just kind of put an equal sign here and then work on the right side until I get the left. All right? So this right side is equal to sine squared theta plus 2 cosine theta sine theta. And actually, maybe I should write this a better way. This would be sine theta cosine theta doubled. So let's change that and be a little bit more deliberate. So plus sine theta. Ay. All right. Try this again. Sine theta cos theta plus sine theta cos theta plus, what am I doing there? Cos squared theta. Okay, so I've foiled this thing out. Now, if I rewrite it, this is equal to sine squared theta plus cosine squared theta plus 2 sine theta cosine theta. All right, so again, the sine squared and the cosine squared, I've just moved that here. We know that's going to equal 1. And then these two terms, sine theta cosine theta plus sine theta cosine theta, I've combined. All right? So this is equal to 1 plus sine 2 theta. Done. And what you could do, if you want to make it easier for your teacher to read it, is you can just write, okay, well, that was this part. And maybe another color. And let's just try this gray. This was this part. All right. Done. Okay, we've got this same identity twice, so let's cancel out this first one so we have more space on the next page. All right. Sine squared x, tan squared x equals tan squared x minus sine squared x. So for me, just looking at this again, kind of blind, I'm going to take this side because I know I have to subtract, combine everything, and try and get this. And that might not be the smart thing, but that's what I'm going to try and do. Okay. So tan squared, well, that's really sine squared x over cosine squared x minus sine squared x. All right. I know if I want to combine these, I need a common denominator, so I have to multiply this by cosine squared over cosine squared to combine with this, right? So this is going to equal, and I'm going to combine them in one step. Sine squared minus sine squared x cosine squared x over cosine squared x. And hopefully you can see what I did. So sine squared over cosine squared, that's this part. And this term I've multiplied top and bottom by cosine squared. Got that. And again, because these two now have the same denominator, I just wrote this as one big expression at the top. Okay. So now, let me go back to my pen. Well, actually I need the mouse. Now I've got factoring, right? Sine squared, that can come out. So this is equal to sine squared x 1 minus cosine squared x over cosine squared x. And at this point I'm thinking, well, now I have my sine squared times something, and that's what I want here. So I'm going to isolate that, right? And I'm really just going to take this as my second part and see if I can manipulate that. So this is equal to sine squared x times 1 minus cosine squared x over cosine squared x. Totally fine to do, right? Because this is all multiplication. So this times this divided by this, that's the same thing as just this, right here, times this over this. That's fine to do. And now hopefully we're seeing, oh, this is sine squared. Sine squared over cosine squared is going to turn into tan squared. So hopefully I have room for that. Actually, this is what I'll do. I'll go over here. So this is equal to sine squared x times sine squared x over cosine squared x, which is equal to sine squared x times tan squared x. And then we're done. So sometimes I like to just put that double mark there. So sine squared x tan squared x, sine squared x tan squared x. All right. So hopefully that's useful, guys. We're going to have some practice for you. There's a worksheet called Is It a Trig Identity that we'll attach. And then we'll also put this packet page that's homework, 2 pages actually, page 13 and page 26 up and available for you too. Okay? So one more day, guys, left after this. Wow. Hope you're doing well, and we'll see you soon. All right. Bye.